Thank you. So, good morning. I'm happy to meet you virtually. I wish I could be there, but it's probably a good call that we didn't go from Queensland because we couldn't come back. So, my talk is kind of grandiosely titled Know the Star, Know the Planet Insights on Exoplanet Radii. Maybe, there we go. All right. Better title would be this one is How Galah is Helping the Exoplanet Community. Because I think I'm probably the lone, maybe Jake and I are the lone real exoplanet specialists in this virtual room. So my goal today is to less about presenting really flashy, awesome science results that we've already seen from other speakers, and more about just kind of educating the Galah community as to how what y'all do is really helpful beyond the star botherers and actually to us who like planets. So I will give you the exoplanet person perspective, namely, what do exoplanet people think about stars, how Galah can help, in particular about K2-HERMES, and Dennis just gave a good introduction to what K2-HERMES is, and I'll give it from the exoplanet point of view, and then how TESS-HERMES 2, the TESS ecliptic mission in later this year, is going to give us again more wonderful science. So the sort of iconic picture is 1, there's TESS, 2, there's Galah, 3, something happens, science, and then 4, we profit by learning more about planets. So exoplanet people, we are a weird bunch. So in terms of stars, we didn't really care a whole heck of a lot about stars. They were just sort of these nuisance bright things that got in the way of us finding planets. And so this meme, as the young people say, kind of accurately depicts what exoplanet people think about stars, which is to say, we want planets, and oh yeah, we have to deal with the stars. And what goes by the wayside and gets kind of drowned is working out the parameters of the stars is not something that planet people really cared a whole heck of a lot about. It was always sort of a boutique operation. You go find a planet, and oh yeah, well, it orbits this star. I guess we have to deal with the star. So, okay, let's get the mass and the temperature and the metallicity and all this, and because we have to do it. The referee is going to make us do it. The result is every exoplanet discovery paper, at least in the early days, that first couple decades of planet search, you find a planet, it's got a star, you go off and maybe you get a spectrum and you do some spectral analysis in your own specific way using your own favorite program to do it. And relevant XKCD here, everyone's done it a different way with different 0 points, different normalizations. It's a bit of a mess. So, and as it turns out, knowing the star is important, right? Who knew? Well, this is kind of preach to the choir here, but stars are actually important. So thank you, Galah, for teaching me the real meaning of stars. Transiting planets, when transiting planets started coming really popular, that forced us to care more about the radius of the star. We really started to care more about the planet and the star's parameters because that impacted directly as to the measured radius of the planet. So in 2002, back in the day, I'm old, gray hair, gray beard here. There was one transit planet, and okay, fine. Now we have 4,000 of them. The boutique one-at-a-time approach isn't really that helpful. You need to do all of them in one go the same way. The reason is shown in these plots here. Obviously, if you have a planet transiting a star, the radius of the planet is inferred as a function or a fraction of the transit depth, right? You measure a transit depth, you say the radius of the planet is a function of the radius of the star. So obviously, if you don't know the radius of the star very well, that error propagates through. That gave us the motivation that we need to actually care about the radii of stars. The future is indeed now. There's 4,000 of these things. Let's do it right. So early efforts to do this. This is a plot from Phil Muirhead's paper from a while ago, but it really struck out to me how if you went off and got actual spectra of the stars and did them all the same way, you actually got 1, self-consistent results, and 2, you got results that were quite a bit different from the old way of getting an estimate of radius from photometry, changed by 30% up to 10 to 30%. So that's a lot, right? If you change the size of your planet by 30%, that's a lot in terms of how are you going to understand the interior structure. Jake is going to talk more about that in the next talk. So how can Galah help us? Well, obviously, you have a million stars, all for which you've done the analysis the same exact way, and that's good. Consistency is good. So Shock Pikachu, it works. For us planet people, this is important because we can determine, is a thing that you're seeing causing a transit really a planet? Or is the star so darn big that the inferred radius of the thing is too big to be a planet? That's our main thing. Habitability. What kind of star is it? Temperature matters. Is your planet even vaguely habitable? People like that. You put it in your grant proposals. Okay, fine. Compositions, again, Jake's going to go into some detail about that. K2 and Hermes, as Dennis probably also showed, they match really well. This plot shows the K2 field overlaid with a Hermes field, and it's a good match. Come back there. So K2 Hermes, for those of us who like planets and less about galactic archaeology, I said, hey, look, K2 Hermes is a thing, and we can get all the planet candidates that the K2 Hermes program has observed and work out consistently amongst those candidates what are the masses, the radii, the abundances, the ages, everything. When you do that, and this is a real quick, summary of the papers that we put out, we got 30 candidate planets, sarcasm quotes, candidate planets that have radii that are bigger than any known planet is even possible to have, bigger than 2 Jupiter radii. That's bad, okay? And come on, there's my plot. So this is a table of things with very large radii. Anything bigger than about 20 or 22 Earth radii, not a planet. It is probably a false positive. So we're able to kill planets. Always good fun. So killing planets and also understanding them. So not just killing them, but finding out what about the population of these things. So on the left, you see a plot from the California Kepler Survey, which did basically similar things. Let's go get spectra of all the candidate planets. This case, Kepler is north. And let's understand the population statistics of these things. And so that's where they're able to really tease out the radius gap and other clues into formation and evolution of planets themselves. Because once you get the error bars down from this big honking thing here to this little thing here, CKS, California Tech Survey, or Kepler, you can actually get some structure in the size against orbital period distribution, the so-called radius gap right here in the middle. And we get the same thing, right? This is a much less pretty plot made with good old Super Mongo. You can't beat SM. And it looks like it's 95 again, but you get a radius gap. Fewer stars, fewer planets. It's not as pretty, I know, but we got the same answer. So good. If an idea is a good idea, someone else is going to do it. So of course, the Keck California bunch has done this for the Kepler field in the north. I'm trying for us to do this with the K2 fields that we can get with Gola. It's a good synergy. Future, we can still do this, right? K2 is dead, long live K2, but TESS is a thing. It's a good thing. And soon, later this year, it's going to hit the ecliptic again. So as you see on this, thank you. You see on this plot, TESS ecliptic's going to get 4 sectors on the ecliptic where K2 has data, and hence K2 Hermes has data. Well, K2 only got about 1/10 of the stars in its actual field of view that they actually downloaded. TESS, we're getting all the stars. So there's going to be a whole bunch more candidates out there. We can play this game again because there's going to be overlap between TESS ecliptic and the existing K2 Hermes data that we've already got. Boom, crank the handle, new papers, new insights, more science. I like science. You like science? We love science. Quickly going through, that's the idea of the TESS ecliptic field. So K2 field for comparison, TESS field is this big honking thing, and it's going to be about this region to the right of where I'm kind of putting my mouse. So there's a lot of fields that are overlapped. I'll leave on this conclusion slide here and say, we are excited. We who like planets are keen for the ecliptic mission for TESS. The stellar parameters that y'all get are really useful for us in terms of understanding not just individual planets, but the population of these planets in a self-consistent manner, because we've done it all the same way. Not just for killing planets, which is fun, right? At this point, killing them is more fun than finding them because there's so darn many, but also understanding them. So Jake is going to go a lot more into the details of understanding the structures of planets in the next talk. And I'll leave you with this this nice plot and my email address. So thank you very much.
Thank you, Rob. We have time for a couple of questions. Keith, you have your hand raised. Would you like to just speak?
Yeah, that was supposed to actually be a clapping sign because the
We've all
memes are
been there.
awesome.
We've all been there.
Thanks. Hi, Keith. I'll see
Hello.
you at UT Austin when I get out there this fall for sabbatical.
Yes. Be happy to have you.
Outstanding.
Any other questions before I jump in and ask mine? In the room. Rob, you say you're killing a lot of planets. What fraction have been misclassified? Is this at the 1% level, the 50% level? How alarmed should I be about?
So the latest paper, the one that, this whole talk was an advert for the 2020 paper put out last year. We had 224 so-called K2 objects of interest, right? So candidate planets. Of those 224 planets, 30 of them turned out to have radii that were just incompatible with being planets. So, it's more than 10, it's like 10, 12% of the candidates that we killed.
Not insignificant. Great.